expressions a review. An algebraic expression is a mathematical phrase that is made up of numbers and variables. So you were introduced to some concepts of algebraic expressions when we looked at solving equations earlier in the year. So we're going to review some things that you may remember from grade 9 and even some things that we would have done already in our course. So the distributive property is like the rainbow. So it's only necessary when there is a number directly in front of the bracket. So that's important. And remember that negative and then bracket x plus 1 is the same as negative 1 times x plus 1. So keep that in mind as well as we move throughout this unit. So we're going to simplify some examples using the distributive property, and you can see why it's called the rainbow because when we multiply the term outside of the bracket by everything inside of the bracket, it sort of creates that rainbow effect when you draw those arrows. So 2 times x plus 1, first we do 2 times x, which is 2x, and then we do 2 times 1, which is plus 2, or positive 2. If we take a look at example B, so this is an example where we have that imaginary 1 in front of our bracket. So if it helps you to put it in front, by all means go ahead. So we're going to write our 2x out front first, and now we're going to multiply everything inside of the bracket by that negative 1. So negative 1 times x is negative x, or negative 1x, so you can keep the 1 in front or you can eliminate it. And then negative 1 times negative 1 is positive 1. So once we have applied the distributive property to remove the brackets, then we can combine any like terms. So 2x take away x is x, and then we're left with x plus 1. So let's go through a couple of more examples. So if there is nothing in front of your bracket, again, it's like an imaginary 1. If it's a positive, though, it doesn't change anything inside of the bracket. So for part C, it's just going to be 4x plus 3x minus 1. So if it's just a positive 1 outside the bracket, the terms inside of the bracket don't change at all. So not like they did in part B. So again, it's a matter of collecting those like terms. 4x plus 3x is 7x, take away 1. And lastly, example D, again, we're applying the distributive property, so that we're drawing that rainbow. So we have our 3y out front, so sometimes they're not always going to be x's, and that's okay. And then we have 6 times 2y is 12y, and 6 times 1 is positive 6. And now we collect those like terms. 3y plus 12y is 15y plus 6. So that's the distributive property. So if you needed a review of that, so this is a great section to refer to. So the next thing we're going to look at is, we've already sort of touched on that a bit in reviewing the distributive property, is collecting those like terms. So remember, like terms have exactly the same variable raised to the same exponent. And we simplify equations by collecting like terms, and a simplified expression will have no like terms. So that's important. So you always want to simplify your expressions as your final answers. And when we're simplifying our expressions, we want to make sure that we order from the highest exponent to the lowest. So that's important as well. So if we're looking at simplifying example A, we want to start with the highest exponent. So that is our b squared. We only have one term that has a b squared, so that's what we're going to start with. So 3b squared, And now we're going to take a look at either our A's next or our B's next. And it doesn't really matter. Let's go with our B's since we started with a B squared. So we have a 2B and we have a plus 8B. So 2B plus 8B is plus 10B. So you can go ahead and write that right now, or some people like to write it so that they put their like terms right beside each other first and then simplify. Okay, so either or is fine. So you can go right from your question to 3b squared plus 10b, or you can show that intermediate step, whichever works best for you. And then lastly, we want to look at our A's. So we have 7a and then a minus a. So 7a take away a is plus 6a. So again, you can jump right to this last line, or if you need to show that intermediate step. So if you want to place those like terms directly beside each other first and then simplify, by all means, go ahead and do that. So the next example, again, we're going to start with our exponents with the highest, the term with the highest exponent. So in this case, it's our x squared. So we have a negative x squared and a positive 3x squared. So if you wanted to write these right beside each other, you could. Or if you can go right from your original question to the next line, that's okay too. So negative x squared plus 3x squared is 2x squared. And now we need to look at our terms that have an x. So we have a positive 2x and a positive 3x. So 2x plus 3x is equal to plus 5x. And now we need to look at our constant terms, or our terms with just our numbers, which is a positive 3. So if there's no sign in front of the term, it's a positive out front. And then we have that negative 4. And 3 take away 4 is negative 1. So this last statement is your final simplified answer. If you can go right from the equation to the last statement line, you can. If you need to show that intermediate step, by all means, go ahead and do that. So that's collecting like terms. So remember, we can only collect the terms that have the same variable with the same exponent, okay? All right, so now we're going to take a look at exponents and squaring. So we know from collecting our like terms that if we have terms that are exactly the same variable with the same exponent, we can just go ahead and add those two together. So y plus y plus y is 3y. But when we have y times y times y, that becomes y to the power of 3. So these are like imaginary exponent ones right here. And when we multiply terms with the same base, when we add the exponents together. So I've included the exponent rules down here at the bottom, so that's helpful to refer to as you're continuing on through this unit. So if you're adding and the bases are the same, we can't do anything in terms of simplifying. We just have to write it like we did this first example. But if we're multiplying and the bases are the same, you add the exponents. If you have terms inside of a bracket to the power of exponent, then each of those individual terms get applied to that exponent. If you have a base with an exponent and then to another exponent, you multiply your exponents. And if you are dividing, so if you have a fraction or your division question and you are dividing and the bases are the same, then you subtract your exponent. So you may remember these exponent rules from when we looked at reviewing in the very beginning of the semester, if you remember that far back, or even in grade 9. So let's simplify. So what does a to the power of 3 mean? Well, this means a multiplied by itself 3 times. So this is important for you to remember. So you can write it like this in brackets, or if you wanted to, you could write the multiplication symbol. I may just caution against writing the multiplication symbol, especially when we're looking at algebra, so that you don't confuse those with x's. So keep them in the brackets is my recommendation for you. So what does example B mean? So if we have 2 to the power of 3, well, this is the same as 2 times 2 times 2. So I'm multiplying 2 by itself 3 times. So a common mistake is to do 2 times 3, but that would be incorrect. So it's 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. So you can do that mental math, or you can, if when your questions are larger, if your bases are larger, you can go ahead and use your calculator for that. Remember, your exponent symbol could look like a top part of a triangle, or it might look like an x to the y, and some of you may even have, or sometimes it's y to the x, and some of you may even have a cubed button. Most of you will always have a squared button as well, so things to think about. So all of these are some variations of what you might see on a calculator. And so when we're looking at the next set of examples, this is an example where we want to apply this exponent to each term inside of our bracket. So this exponent 3 is being applied to both the 2 and the y. And we already know that 2 to the power of 3 is 8 from example B, so it becomes 8y to the power of 3. So we can simplify or solve for the exponent when we have a number and just keep our variable right there. So then the last example that we want to take a look at. So here we have a combination of exponents and distributive property. So remember, this is like that imaginary 1 in front of this bracket here. So we have 3x out front. And now we're going to apply this power of 2 to both terms inside of the bracket. So we can do that by taking -3 squared and -3 squared. So we can show that there. And then we can also do x squared. So if you need to show that step, by all means, go ahead and show that step. If you know what -3 squared is, you can do that as well. And then we're going to apply that -1 to both terms inside of this bracket, so using the distributive property. So -1 times x is -x, and -1 times 1 is -1. So now we want to solve for our exponent in this next line, and we could also even simplify some of our like terms as well. So we can do that all in one step if you want to. Or we can show multiple steps, that's fine as well. So I'm going to write it as multiple steps. So I have 3x, and then 3 squared, or -3 squared, is -3 times -3, which is +9, and then 9x squared. And then we have a minus x, and we have our -1. So when we rewrite this, we always want to start with our highest exponent. So that is our 9x squared. And we want to take a look at combining or collecting any like terms from before. So we have a 3x take away an x, which is a positive 2x. And then we have our constant, which is -1. So we've combined a lot of our skills in that review in this single question. So refer to this questions if you need to moving forward. We're going to take a look at some more examples that are going to be very helpful for you and skills as we progress through this quadratic expressions unit. So you need to remember how to substitute values into an equation and solve. Again, we've done this when we've looked at our geometry unit. We've done this when we looked at, when we reviewed Pythagorean theorem. You essentially have done this throughout the entire course, but we're just going to review it just for kicks. So we are going to substitute in the value of 3 in for any place that we see in x in this one, first example. So we have 2 times 3, or 2 times x, and then plus 3. And 2 times 3 is 6, plus 3. So that equals 9. So that's just as simple as it gets. And then we're going to keep going through a couple of more examples. This time we're going to place -4 in for our x. So we have 2 times -4 plus 3. 2 times -4 is -8. and negative 8 plus 3 is negative 5. So remember to use BEDMAS as you are solving. That's really important. So we have to do our addition, our multiplication and our divisions before we do any additions or subtractions like we did here. And when we get into those ones with exponents and brackets, you're going to have to do those first as well. So remember BEDMAS. So for part C, we have 4x squared. We're going to substitute in the value of 2 for our x. So we have 4 times 2 to the power of 2. So this looks like we have to do our exponents first. So 4 times and then 2 squared, or 2 times 2, is going to be 4 again. So we have 4 times 4, which is 16. And the last example, again, we're going to substitute 2 in for the value of x. So it looks like this. So 4 times 2 to the power of 2. So this time we have to simplify what's inside of our brackets first before we apply the exponent. So we have 4 times 2, which is 8, and then 8 squared, which is 64. So that's why it's so important to use BEDMAS and to remember BEDMAS as you're solving algebraic expressions. So the next thing that we're going to look at is factors of numbers, and then we're also going to look at integer pairs. And this is going to be greatly important when you are factoring quadratic expressions. So factoring relies a lot on those mental arithmetic skills, so those multiplication tables, which you probably were drilled into you in elementary school. That's going to come in handy hugely for this unit. So what is a factor? Well, a factor is a number, or sometimes even an expression, that will divide evenly. So there's no remainders. Divide evenly into another number or an expression. So an expression is like 3x, right? So it's a combination of letters and numbers. So think about that. So when we're looking to find factors of numbers, for example, we want to think about what numbers divide evenly into, for example, part A, into 20. So what are those numbers that divide evenly into 20? Well, 1 will always divide evenly into any number, so you're going to start with that. And then I like to go up. So I like to think about, okay, what is the number after 1? Well, that's 2. Does 2 divide evenly into 20? Absolutely. So that's going to be a number. What about 3? Does 3 divide evenly into 20? No. So then I go to 4. Does 4 divide evenly into 20? Yes. What about 5? Yes. 6, 7, 8, 9, 10, no. None of those do. And then, 10 does. And then the next one would be 20, right? So you can think about these factors as well as numbers that can multiply to give you those values as well, right? So 1 times 20 gives you 20. 2 times 10 gives you 20, and 4 times 5 gives you 20. So all of these numbers divide evenly into 20, but we also have to remember that not only positive numbers will divide evenly into, but negative numbers as well. So we will also have -1, -2, -4, -5, -10, and -20. So we have to include those positive and negative integers, or positive and negative factors, because may not always be just integers. They could be a combination of integers and variables. So remember that. So let's think about all the factors of the number 75. So what numbers divide evenly into 75? So let's start with 1. 1 does? Absolutely. Then we need to go up. It's not an even number, so 2 doesn't. But 3 does. 4 doesn't, but 5 does. And then at this point, then it just becomes multiples of 5. So 10 doesn't, but 15 does. And 20 doesn't, but 25 does. And then the last number would be 75. So 1 times 75 is 75. 3 times 25 is 75, so think quarters. And 5 times 15 is 75 as well. But remember, it also includes those negative factors as well. So -1, -3, -5, -15, -25, and -75. And you're also going to want to think about integer pairs as well. So this is the last thing that we're going to review. And again, this is going to come in really handy when we're looking at factoring. So sum means addition or add. Product means multiplication or multiply. So you may be asked to find or look for numbers that will add up to a certain value and that will multiply to a certain value. So here's my integer pair, so 2 and 3. What do they add up to? Well, 2 plus 3 is equal to 5. And what is the product? Well, 2 times 3 is equal to 6. Pretty straightforward. So let's take a look at what happens when they're both negative. So -2 plus -3 is the same as -2 subtract 3, which is -5. Remember, a positive and a negative sign right beside each other makes it into a negative. -2 subtract -3 is -5. And now we need to multiply. So -2 times -3 is also 6. So that's why when we talked about those products, so we also have to think about, so sometimes your values can be positives and sometimes they can be negative. So that's why that's important to think about there as well. So then the next integer pair is 3 and -4. So 3 plus -4 is the same as 3 take away 4, which is -1. And then we need to multiply these two values together. So 3 times -4 is equal to -12. So remember, sum is addition, product is multiplication. So sometimes you're going to have to work backwards, and that's important, especially when we're factoring. So we have to determine what the integer pair is that'll make both of these things true. So what two numbers will add to give you 5 and multiply to give you 4? Well, it helps to think about the factors first. And then we can find the set of values that will make it work. Or find or pick, whatever you want to, phrase you want to use. So let's start by thinking about the products of the value 4. So what numbers will multiply to give you 4? Well, 1 times 4 gives you 4, and 2 times 2 gives you 4. But we can also have the negative values. So we can have -1 times -4, because 2 negatives will also give you a positive value. Or we could have -2 times -2, which gives me 4. So these are the products, these are the integers that will multiply to give me 4. So we have our set that of positive values and we have our set of negative values. And now we need to think about which one of these sets of integers will add up to give us 5. In this case, it's the first set. So our integer pair is 1 and 4. So now let's take a look at -16. So the only way we can get a negative integer as our product is if we have one positive and one negative. So let's find our values of that multiply to give us 16 first. So we could have 1 and -16, or we could have -1 and +16. So that's 1. We could have 2 and negative 8, so 2 times negative 8, or we could have negative 2 and positive 8, or we could have 4 and negative 4. So those are the only products that will multiply to give us negative 16. So one of our terms is positive, one of our terms is negative. So which one of these sets, when we add them together, will give us negative 6? Well, our 1 and 16s don't. What about 2 and negative 8? Yeah, absolutely. So let's choose that as our integer pair. So 2 and negative 8 are the numbers that will multiply to give you negative 16, and those same two numbers will add to give you negative 6. So now let's take a look at the last one. So again, we have a negative product, so that means we have to have one positive and one negative. So what numbers multiply to give you 27? So we can have 1 and negative 27, or negative 1 and 27. And then what are the other numbers that will multiply to give you negative 27? Well, 3 and negative 9, or negative 9 and 3. So these are the only sets of numbers that will multiply to give us negative 27. And now which one of these will give us positive 6? Well, none of the first two do. So 1 and negative 27, no, that doesn't work, and neither does that one. What about 3 and negative 9? Nope, that doesn't work. So negative 9 and 3, I made those both the same. Let's try that again. So your last one would be negative 3 and 9. And negative 3 and 9 will give you 6. So these are the factors that you want to look at. So your multiplication facts will come in really handy. Understanding what the sum means and the product means is going to be very handy, and working backwards is also going to be very handy. So these are some basic algebra review skills that you're going to need to know to be successful in this unit. If you have any questions, please put them in the appropriate discussion board or send me an email.